So one little definition to add on to bijective functions. If f from a to b is bijective, then every element of b has exactly one preimage, and we can define an inverse function which is denoted by f inverse, and it goes from b to a, so the domain and codomain switch places. And it's defined by sending b to its unique preimage a. So essentially, when you have a bijection, that means you're matching up the elements exactly on both sides. So you can define a function the other way, which is essentially just the same matching. But we're thinking of these functions as operating in opposite directions. And let me just make a quick note, not to be confused with reciprocal. Which would mean, for example, if you had a function to the positive real numbers or something, you could define a function whose values are 1 over that. That's different from what we're talking about. That would be a reciprocal. But this, we're talking about inverse in the sense of inverse functions, which is a function that goes in the opposite direction. So let's give one quick example. We saw that f of x equals x squared is not injective. Did we see this? Maybe this was just my example for increasing. So let me just say that we didn't see this, but you know what? It's true. This function is not injective or surjective. If we're thinking about it as a function from the real numbers to the real numbers. But if we change the domain and codomain, we can make it so that it is injective and surjective. So let's restrict to r plus to r plus. So this, you may remember, is positive reals. And if we define this function the same way, it is injective and surjective. Because the problem here was that, first of all, it's not surjective because you don't get negative real numbers. So now it is surjective. And second of all, it was not injective because a number and its negative go to the same place. So now we've gotten rid of the negatives and it is injective. So it is bijective. And its inverse function. So remember, well, this is not a good example of this, but we switched the domain and codomain. In this case, they were the same, so you don't see it. And remember, I want to distinguish this from the reciprocal. So it is not 1 over x squared. That is not the inverse function, that is the reciprocal. What it is the function that takes x squared and gives you back x, which is the square root function. So this is an example of inverse functions.